In the last couple of videos, we've taken a look how to make a syringe clamp and a syringe cap that's going to go on the top of the syringe that we're going to use to make our syringe arm excavator. And what we're going to do today is we're going to take a look at how to make the syringe. And I always like to point out that when you're using a design program like Fusion 360, that really it's not the place to do your design. It's a place to do your modeling, your simulation, your testing, and all that. But before you start doing it, you've got to have a plan in place. And the best way to develop a plan is to sit down with pen and paper, or pencil and paper, I should say. And if you need some specific measurements, break out your vernier calipers, break out the calculator so you can calculate what angles you're going to need, and break out the Tim Tams because your brain's going to need a snack as you go along too. Okay, and so this is the sketch that I did, taking a look at how these syringes are actually going to be built. And by thinking about the geometry, I realize a couple of things. First of all, they've got this luer lock tip at the bottom of them. And it's the exact same basically on all of the 10 milliliter, 20 milliliter, and 30 milliliter syringes. So it's maybe worth taking the time to model it once. But when I think about what we're going to use this model for, and which is basically to get fit and geometry and tests. And when we actually build this, we're going to have a tube coming off of right here. And the bend radius of the tube is a far more significant thing than the actual, millimeter dimensions right down here. We're going to simplify that into just kind of a cylinder right at the end and not worry about the fine detail right in there. You can always come back and make a more refined one later on if you feel you need that, or if you want that so that you've got the world's most beautiful rendering of your design. But we're going to be able to get close enough to the part that we need and save ourselves a whole bunch of modeling efficiency by just simplifying some of the less important parts of our design. It's still going to look beautiful, don't get me wrong. We're just going to save ourselves a little bit of work today by not going into the intricate details of the luer lock tip right here. If we were getting really fancy, we'd even have to model a bit of thread in there, because if you can, I don't know if I've got a tip showing on there, but there's thread inside so that you can really lock your tubing on right there. Looking at this and just looking at the geometry and how it comes together, there's a number of ways of making it. It's kind of conical down here and then very cylindrical up and down right here. And you could start doing an extrude and bringing it right down here, but that's not going to be the most efficient way. Anytime you've got an object that is basically cylindrical type of shape that you could make on a lathe, for instance, look for the center line and see if that center line revolves, has a shape that revolves around it. Because we can take this outer profile right here, give it a center line, and then we can revolve this part around the center line. And then what we can do is we can come back and we can pop the top flange on at the top. So I've gone through, I've taken some measurements, and I've taken a few more measurements since I did that drawing. So I've got my notes on there. I'm just going to drag it off to the side and put that on my other screen so I can get started here with a new design. And what I'm going to do is I'm starting with a new design, and I'm just going to save that as syringe body before I get started. And you know what? I'm going to start with a 30 milliliter syringe body right here. I'll model 3 different syringe bodies, but I'll make it parametric so that once I've got one of them done, the rest of them should be easy to do. Okay, and even when we're going to use the revolve command to create our part, we are going to start off by going into sketch and creating the sketch of the profile that we want to revolve. So let's create a sketch, and you can pick whatever plane you want to work on. When it comes time to assemble them, it's not going to matter that much. And let's give ourselves a construction line to work around right here. And we'll just take that line right there and we'll start right at the origin. And let's see, our tallest syringe is actually, let me drag that down a little bit right there. Our tallest syringe is going to be the 30 milliliter syringe, and it's 118 millimeters high. So let's just set that line right there and click that little green check mark. And now we've got a construction line that we can start working around. and I will turn off the construction right here so that we can get started creating our profile. Okay, so now I've taken some measurements earlier, and like I say, we're going to simplify this tip right here. And so what we're going to do is we're just going to draw a line right here, and our profile is going to come out this way. And officially that's going to be 4.5 millimeters. We'll come back and we'll tidy that up in just a moment. And then it is going to come up this way, and it is going to come up 8 millimeters. So I'm just going to put that in right there. It is going to come out at an angle this way, and I don't want that to lock to any specific angle right now, so I'm just going to hit that right there, and then it is going to come up to a height somewhere right in here. And now I'm going to say that's okay. And now I'm going to come back and I'm going to tweak those dimensions that I've got coming along right here. So I said this one right in here was not 5, it was 4.5, and that'll be pretty standard for most of the drawings. This one right here was not 9.8, but it was 8 millimeters. And we've got a couple of ways of dimensioning this. You can dimension the angle, and what I found was that you can dimension from this point to this point right here. You can get an aligned dimension. We don't really need that. We know that that is going to come up here, and that actually from that 8 millimeter tip where that comes up, that only comes up about 2 millimeters. Okay, now that shrunk that in a whole bunch because it was keeping that angle for it, but that's okay. That's not to worry right in there, because what we're going to dimension now is our distance from here to the center line. And this is going to form, well, it's going to be our outer radius, so 1/2 of our outside diameter. And on the 30 milliliter syringe, it has an outside diameter of 23.5 millimeters. So this will be 11.75 millimeters out to right there. And that's going to give us our 30 milliliter syringe. Right, one more dimension, the height. And so the dimension from right here down to right there is, on the 30 milliliter syringe, 118 millimeters. Okay, now this line right here, we've got a couple of different things that we can do to draw the inside part of it. And what I'm going to try first is doing an offset of it, because I took a couple of measurements, and pretty standard wall thickness is about 0.75 millimeters. So if we take that line and I can never remember if it's under create or modify. There you go. You could just type O for offset if you want, and take this line right here, and we're going to drag it that side. And as you can see, it's a pretty smart offset feature. It actually comes up and inside right here. So I'm really, really liking that feature. And it is only at minus 0.75. That gets us on the inside right there. And so that's pretty fine. That's good. And then just to finish things off, come into the end right here and draw a line connecting this end to that end. Zoom in down here. Pardon all my random zooming. Okay. And then we draw a line to finish things off at this end. And you'll see that goes blue, indicating that we've got a solid model all the way across there, an enclosed profile that we are going to be able to rotate. All right, that is our sketch, and it looks about right. Let's finish the sketch and see what it looks like when we rotate it. So we're going to come in here and we tell it we want to create a revolved object, and our revolve dialog pops up in here. And it says one profile has already been selected. That's our blue line right there. It needs to know the axis to revolve it about, and that's why we made that handy line right there. And now you can see that is revolved around and created that part as a new body. And that looks surprisingly like a 30 milliliter syringe. Proof will be in the pudding when we come back to modify the dimensions, and then when we go and create a drawing of it and print them out when we're all done. So there we go. That looks okay. I like that. And now we just need to put a flange on the top right here. So to create that flange, we're going to create another sketch, and we're going to create the sketch right on that plane right there. There we go. So now what's happened, it's not only aligned that plane with a center right here and aligned it all right around in here, but it's also lifted us up in three-dimensional space. So we're right, what we're doing is we're creating our sketch right on this edge, right in here. Okay, so there's a few things that I noticed when I was marking this out, and that was that the object is symmetrical about two axes. So we can actually create a construction line right along here. Now, before we do that, I am just going to do a projection, and I'm going to project the outer circle right on there, just to make sure that we've got those edges available to measure to, and also that we've got the centering position for it right on there. So let's create a construction line, and let's go OK. And actually, I had construction turned on. We created that as a construction line. That's perfectly fine. And let's create a construction line that comes right through here. Actually, let's draw it right to there so it comes to the origin, out to here, check mark that, and then we'll place a point right here. And that's just to make sure that these all know that they're starting right at the origin and coming out at 90 degrees. Okay, so those are all perpendicular to each other and all based at the origin right through there, so that when we use that to do some mirroring, we've got some axes to mirror our lines about. And what I'm going to do right here is just looking at the geometry as I sketched it out. I'm going to turn off my construction lines now. I want some real lines right here. And I'm going to approximate this geometry by saying, well, at the outer edge, it's kind of rounded right in here. And the distance from this edge right here, that outer edge that we projected, to that one right there, the wall thickness at that flange up at the top, I measured that to be about 3 millimeters. So that comes out that way, about like so. And on our 30 milliliter syringe, we've got a line that comes out, and it comes to about 20 millimeters out this way. Okay, so somewhere 20 millimeters from center to edge right out here, we've got a point that's going to come right up here and come around and form a line that comes out tangent to that. So we're going to start by adding a line coming down right in here at about 20 degrees and another line coming up from right here. So this one's going to come in here, and it's going to start somewhere in about right here, and it's going to come up pretty vertically right here, and then it's going to come over here, and it's going to join and be coincident with this circle and tangent to this circle. So you can see I've got that X indicating that I've got a lock happening on right there, and right now it's not tangent, but we'll take a look at that in just a moment. Okay, so we've come in there, and that one is not tangent right now. Let's just hit escape so we stop drawing lines. We've got all of our constraints up here, and we can apply constraints to things, and we can tell it, I want this line to be tangent to that line right there, and you can see that snaps in and it makes it tangent. Now, if you ever want to see what the constraints are on something, just click on it and click what it's connected to, and you can see right there that I've got two constraints showing up. One saying that it is coincident, in other words, that it means that they have to touch, okay? And the other one saying that it's tangent, the point at which it touches is going to be tangent to that circle right there. Down here, you can see this line has a constraint saying that it is going to be vertical. So I'm good with that. This is a rough outline of what we got. Now, of course, it's rounded in the corner on our syringe, and that's easy enough to add with a fillet. Let's add a couple of dimensions first. And we haven't dimensioned an angle before, so we're going to take this line right here, and we're going to dimension that line relative to the vertical line. And I did a little bit of measuring and math earlier, and it's going to be 20 degrees off the vertical, so I could either measure 110 in that direction or 70 in that direction. And just for the point of keeping it off of the drawing, I'm going to measure it 110 right in there. Okay, and you can see that just changed the angle. And although it looks like it carries on past here, really the line that we're looking at right here comes in as coincident and tangent. That's just a measurement line coming out right there, a little extension line for doing our measurements. Okay, and I've measured the large syringe, and I know the dimension from right here to the middle. Let me find an appropriate place. Actually, why don't I put it up here? The rest of my dimensions are up here. That's going to be about 20 millimeters in the large syringe. And then we are going to fillet this corner right in here. And it's got a little bit more than 2 millimeters radius on the fillet. Let's go with 3. And I think that'll approximate, close enough for our purposes, the shape of that corner right there. Now, like I say, I only drew 1/4 of the overall object because we can come along and we can use the mirror command right here. Technically, we could probably do a circular pattern, but let's use mirror. And I'm going to take that object, that object, that object, and then I'm going to select my mirror line right here. And it's going to pop across right there. I'll say that's okay. And then I will do another mirror command, and I'll take this object, this object, this object, this object, and then I will mirror it about that line, and I'll say okay. And now we've got something that looks kind of like the flange that comes off the top of the syringe. We can finish our sketch. We can rotate this around so that we can see what we're looking at right here. And let's do an extrude. And we are going to extrude this, this, that. Don't forget to extrude the edge. Now what's interesting is it's going to extrude it up this way, but the way I took my measurements, I measured from the top of the flange to the bottom of the tip. So I want it to extrude down in this direction. So instead of extruding a positive distance, I want to drag it backwards and go a negative distance. Now normally when you extrude in a negative distance, it automatically turns into a cut. We're going to tell it we want it to be a join. And the distance that we want to have our negative extrude go through there, the flange thickness usually comes out to a dimension I haven't measured. Let me just grab my calipers and take a look at that. That comes out to about 2 millimeters. So negative 2 millimeters right in there seems representative of flange thickness. There we go. And that is looking like a 30 milliliter syringe body. So there's one more thing that we want to do. I'd like to make this a little bit transparent, kind of translucent. So to make it transparent or to make it look different, we can come under modify and we can change the physical material. And the physical material does more than just change the appearance. the physical material actually changes properties such as density and strength, so that if we were to do an analysis on it, it would change the weight of the syringe, and it could tell us exactly how much it was going to weigh and all sorts of good and useful things like that. Let's see what plastic choices we have available to us. And they've got acrylic, clear, epoxy resin. We're looking for something kind of translucent. It's probably made out of something like polyethylene or polypropylene. So we've got a polyethylene terephthalate plastic that we could try in here, a PET, and that makes it somewhat transparent. And but it's not entirely transparent. It's somewhat opaque, and that might be good later on, just as we put uh, the syringe plunger inside it, just so we can see it moving up and down in there. You can try a different material if you want. That was PET plastic. It's a little bit too clear. It's got all sorts of interesting ones in here. You could put a phenolic resin on it. I don't think we want that. Get rid of that. Uh, Unassign and delete. What else? Steel, unassign and delete. We don't need that in there. That on there. Okay. Anyways, we're dragging that around. We're goofing around. Drag your PET plastic on there, and it ends up looking pretty good. Oh, here's polyethylene. This would probably be a high density polyethylene. That might be a better finish, except, oh, it is. Is it slightly transparent in there? Ooh, that does really look like polyethylene. You can just barely see through it from some angles. If you're ever unsure, you can always render it up. Mm, I think I like the PET better. It's not exactly what it looks like, but for our modeling purposes, I think that's going to do great. Okay, so I'm going to call this the 30 milliliter syringe, and that's going to be the body, and I'm just going to save it. Okay, then I'm going to go through and I'm going to change some of the dimensions on it so I can get a 20 milliliter syringe. So right now I'm just going to go save this as syringe body 20 milliliters. So make sure it's saved under a new name. And then I'm going to go change some dimensions. Whoa, musical interlude. Thank you very much. That song came from bensound.com. They give away some free samples to put into your videos, and I actually like some of them. There's another musical interlude coming up, so don't go too far away. So what you should have right now is you should have three syringe bodies stored over here, the 10 milliliter, the 20 milliliter, and the 30 milliliter, all done to their correct sizes. And if you're off by a little bit on the dimensions, well, if something doesn't fit, you can probably go back and tweak it together. Well, now what we're going to do is we're going to create the plunger that comes up and down inside of this syringe. And so I'm just going to close this file for right now. And I'm going to start by saving this file into the Syringe Excavator folder where I'm doing all my work. And I am just going to call this plunger cap 10 milliliters. Actually, I'm just going to call it plunger 10 milliliters. I'll talk about why I don't need to separate the cap out here in just a moment. And I'll go ahead and I'll save that. So, okay, here we go. We're saving the plunger 10 milliliters in here. Now, everything we've done up till now, when we've created the parts, we've created something that Fusion 360 calls a body. And so if we come to our list of items over here and we look down underneath here, there's name views, there's document settings. When we come in here, you'll also see in a lot of your drawings that there'll be bodies in there. Well, what we're going to do now is we're going to take it to the next level because the plunger cap is a different material from the rest of the plunger. And so what we're going to do is we're going to create the plunger cap as a new component. So components are like pieces that you can put together inside your drawing, whereas bodies are the pieces. So if you think of your Lego Star Destroyer as being one big component that you could then come along and put into an entire Lego battlefield, the individual bricks that make up the component are the bodies. They get all pieced together to become a component. But to make it so you can do it, you can also make those individual blocks components. That makes it easier to piece them together into one massive component. So here we've got component 1, and you'll see that this little dot right next to it is turned on. That means that's activated. That's not a big deal right now, but I'll talk to you about why that's an important thing in a little bit. So now we're just going to carry on like normal, but instead of making a body underneath plunger, we're making a body underneath component 1. And in fact, I'm going to come in here, and just so I can keep track of that, I'm going to rename this. And where's my rename function in here? We may just click on it once again. There we go. Just click on it right there. And I am going to call this the plunger cap. Okay, and here we go. Let's create a sketch. And the plunger cap is the little black thing at the bottom of the plunger. And again, before I started doing this, I sat down and did some sketches. So I know that I want to create a rotational object. So I'm just going to bring that right down there, and I'm happy with that. I made that a construction line. And then I am going to take a line right here, and it is going to come out a certain distance right here. We'll get that distance just right. It's going to come up over here. We'll get those distances just right. It's going to come up over here, and then it's going to come back down. And that should become a final shape. I'm not sure why it's not showing me as, there we go. So I had to come back and just create that extra line coming in right there so that you can see that went blue, which means it's an enclosed shape. Now I'm going to apply some dimensions here, and I've already done my measuring. So I know that right down here, I want this dimension to be 3.75. And I want this vertical dimension from that point right there to that point right there to be 2 millimeters. And that I want my 10 milliliter syringe is going to have an inside diameter of 15 millimeters. So that will be a 7.5 millimeter radius right there. And that is the approximate dimensions of the plunger on the 10 milliliter syringe. Just holding up mine to take a look at it. And oh, I'm missing one dimension right here. I need to tell it how tall it is. That's why it looks wrong. It's too tall right there. And the measurement on there is 7.5 millimeters for a 10 milliliter. Ah, it looks big, but that's because I haven't rotated it yet. Let's just finish the sketch right here. Okay, and we'll take a look at it in a three-dimensional perspective. And then just like we did with our, we've got one profile selected. Let's select the axis, and that looks more like what it should be looking like. And I will just say okay. And here we have that little plastic cap at the end of the syringe. It's going to be in black plastic. So what I'm going to do is just right click on the plunger component right there and I am going to go physical material, and it's not an acetal resin or a GFRP. It is plastic opaque black. It's actually something stretchier than that, but we're not going to be running stress tests on this. So there we go. We've got a plunger cap right in there. And so now I am going to close that because I'm happy with that material. And I've got my plunger cap in here as a component. Now I can come along and I can create a new component. And it's going to ask me, where do I want to start drawing for component 2? Well, I'm going to start drawing component 2. This is going to be the shaft of the plunger, and it's going to come up right from that plane right there. So by clicking that on there, I can come in here and call this plunger shaft or piston shaft or whatever you want to call it. And we are going to start by creating a sketch right on that plane where we began. And all we're going to do is we're going to project the outside diameter right there. And then we are going to finish that. And we are going to extrude this up. Oh, why did it pop me back into sketch? I did something wrong there. Finish sketch is what I want to do. I must have clicked on the create sketch instead of the extrude. I want to extrude that by a distance of 1 millimeter. Okay, and now you'll see something interesting happen right here is that because I've got the plunger shaft component selected, you can see the little dots on there. I'm doing all my work inside plunger shaft, and it's kind of grayed out the plunger cap on there. Alrighty, so now we need to create the cross section that extrudes all the way up to the very top end of the plunger. And so we've got some dimensions that I may have shared with you in a previous tutorial. And the dimensions that we're looking at are right on here. So for the 10 milliliter plunger, we've got a cross section right here that is going to be 1 millimeter in thickness and 9.5 millimeters wide, centered on there and in a cross pattern. So let's just move that off to my other monitor right there. Hope you had a chance to jot those dimensions down. If not, you can always rewind a little bit. And let's create a new sketch right on here. And so this is time we want to create a new sketch. It's coming in right on here. And we're going to start with some construction lines just so everything comes in nice and square relative to that origin right there. So let's draw some lines. And construction line from the origin. We'll just bring it out to here. Happy with that. Origin out to there. Happy with that. There we go. So I've got my construction lines all marked out to show that everything's going to come in here quite nicely. We've got a couple of different ways of drawing this in here. And I think probably the quickest and easiest way is to go with rectangles and draw, oh, excuse me, turn off our construction line. We want these to be solid lines now. And we'll draw one about like so for our vertical rectangle. And we can dimension that as being 1 millimeter. And then what we'll do is we'll dimension from here to that line as being equal to this one divided by 2. There we go. So now we've got our width of that line. We just need to create the height of that line. And the height of that line on this one was 9.5. So this dimension right here will come out to 9.5. And to keep it nice and centered in there, we'll dimension from there. Hit escape. I don't want that dimension. I want dimension from the top right here to that line. Okay, sip of coffee, calm down. Dimension, that line to that line. Escape, escape, escape. This line to that line. There we go. Okay, so if you're having problems clicking on things and getting them to come up, I understand. Sometimes you get going and you just have to go back, and thankfully there's always an undo button that lets you sort things out. And there we go. So there is one rectangle right on there. You've got a few options in here. I mean, you could have just drawn it as kind of a V shape in here and then mirrored it or rotated it. I could rotate this into a different position. There's all sorts of ways to describe this, but now that I've got the dimensions all figured out right here, I'm just going to draw that rectangle in there. I'm going to dimension right here, and I'm going to set that dimension to be the same as the dimension right up there. Okay, so that automatically becomes 1. I'm going to dimension from there to there, and that is going to be automatically the same as up there. Okay, so I'm deriving those dimensions from other parts of the drawing, and right here is going to be the same as right there. And the dimension from, let's see if I can draw this without jamming it up this time, from that line to that line. Yes, I know it's 90 degrees. We don't need to dimension it as 90 degrees. I don't know why this one is not cooperating. I want to dimension from right there to right there. I didn't have dimension turned on. Dimension. Hit escape several times, clear out what you're doing, pick the line that you want, pick the next line that you want, and tell it where you want the dimension, and then tell it what you want the dimension to be. All right, there we go. And so now we've got the profile that we're going to extrude to form the basis of the shaft. And we'll take that back to a 3D view, finish our sketch. And so this is going to come right out of here, plain old extrude. And make sure you get all of your surfaces included. And there we go. This one is going to extrude out here for the 10 milliliter syringe. That one has a height of 89 milliliters between the little plastic rings. Okay, and now we're going to come down to this end right here, and we're just going to put the cap on that plunger right there. And we're going to do that by creating a sketch right here. And this sketch is going to be fairly easy to do because it will be a circle centered on the origin. And for a 10 milliliter syringe, we will dimension that to be, what did we say, a 17 millimeter diameter for a 10 milliliter syringe. And we will finish that sketch, and let's take a look at it right here, and let's do an extrude of that sketch. Okay, and we're going to take this profile along with it. So otherwise you'll end up with a cross gap in the middle of it, which would look kind of ugly. And that is going to extrude a height of 1.4 millimeters. And there you have it. There is the plunger shaft. Now we want to apply a material to that. And let's come in here and find our physical material. And let's make that just plain old ABS white. And that should show up inside of our much more transparent outside syringe, because later on in this tutorial, we're going to link the two of them together and let them slide together. Okay, going to close that physical material right there. Now you can see that this is still kind of grayed out. If I come back to my plunger up at the top and make the overall plunger the active component, now you can see that we've got the cap on the end and a simplified model of our plunger. We don't have all the fine details right in here. If you're feeling a little bit OCD, go ahead and add them in. The computer will be just happy with that. So what I'm going to do now is go ahead and create plungers in the 20 milliliter and 30 milliliter sizes. Okay, there we go. And that was just a quick review of some of the dimensions in case you missed them as I was typing them in. So now you should have off to the side, you should have a 30 milliliter plunger, a 20 milliliter and a 10 milliliter plunger, and a 10 milliliter, 20 milliliter, and 30 milliliter syringe body. And now what we're going to do is we're going to assemble them to create the actual syringe itself out of these components or parts that we've been building all along. In order to do that, you need to start with a new design right here so you can close off all of the other designs that you have right up here. And one design, and we don't like that being called untitled. So what we're going to do is we're just going to save that file. And instead of calling it untitled, we are going to call it actually, let's call it the 30 milliliter syringe. No. We should keep the first name right so that all our syringes show up next to each other and then they're sorted by their size when we look at them in our hierarchy. Okay, here we go. So we're making a syringe 30 milliliters. So the first thing we need in order to do that is we need a syringe body. Well, actually, let's do the plunger first. It's probably easier if we take a look at a few of these things on the plunger. So let's bring the plunger in right here. And all I did was a drag and drop and drop that right into the middle here. And Fusion just processes that. And now I have a plunger right in the middle of my diagram. Now, what this is all about right down here is if I want to position it somewhere else, but right now I'm happy to have it come in right at the origin, and I'm just going to click OK right on there. So this is not that far different off what we had before, except you'll notice if I pick it up and move it, those two parts separate, and we don't want that happening. So what we're going to do is we're going to assemble those by making a joint between the two of them. Joints can be a whole different range of joints. You can have sliders and cylindrical and rotational joints. This is just going to be a rigid joint right here, and we're going to assemble that. Some components may have been moved because I dragged that to show that they weren't connected. So I'm just going to click as continue. It'll put it back where they were to begin with, which makes creating the joint fairly easy. And now if you take a look right in here, you can see that I'm going to zoom in right here, and I'm going to select a location on that component that is going to be our joint, and that's right at the middle right there. And the location on the second component is also in the same spot, and I'm not going to move them around. You can see that wiggling back and forth because that is a rigid joint. And you can check out some of the other joints that you could have. You could create a revolute joint where it can spin, a slider joint where that can slide, a cylindrical joint where it can slide and spin, a pin and slot joint where it can slide and translate, planar joint, so it can move just about anywhere on that plane, and a ball joint where it can wibble around like a ball. So very mechanical thinking. This one though, the plain, boring, rigid joint, it's not going anywhere. Those two are connected together, and we'll just click on OK right there. And what you'll see has happened down here on our timeline now, we've got the component insert, the first thing that we did, and then we've got the joint that we made, a rigid joint, joining those two together. And you'll see in our table right up here, we've got a new entry for joints, and that is rigid one. If you want to do a good thing in here, you could come in and you could rename that cap to plunger. Not that the program cares, but now if you come back and take a look at that, you'll know what that joint is. And as you start to get more and more joints into an assembly, it's nice to be able to have them named so you know what they do. Okay, so we've got this all put together, and this was a 30 milliliter syringe we're making, so we need a 30 milliliter body for it. So again, drag and drop. And there is our 30 milliliter syringe. Now, I'm not 100% happy with where that's sitting right now, so I'm just going to use that arrow and drag it down right to about right there. And we'll just click OK. And now we've got our plunger inside our syringe. Now, the challenge with that is if I move my plunger, it just moves around everywhere. So we want to create a joint to hold the plunger inside the syringe. And that is going to be a cylindrical joint because it can slide back and forth this way, but it can also rotate while it's doing that. So what we're going to do is we're going to come to assemble. We're going to tell it create a joint for us, please. Again, some components have been moved. I just moved that out of there. We're just going to continue. It'll put it back where it began. And what we're going to do is we're going to find a connection point right on here, right along that center axis. Okay, and then we are going to join that to that center axis. And if we come in here and select motion, actually it didn't bond in there. Come back to position right here. Simple. Oh, we still need to select the second one on here. So we picked syringe body. There we go. I've got to get the syringe face. And look at that. Those two just slide together right in there. And that became a rigid joint. So it does take you a moment to make sure you've got the correct connection points. If you ever mess up, you've got really good undos. Just undo, go back in there. It takes a while to get used to picking the different connections. And come in here. We don't want a rigid joint. So I just went on the next tab here. Or slider might work, but cylindrical is a better representation of what we've got going on right here. And if you click on the little animate tab now, you can see why that works better. Now, obviously, that's going to run into some problems in real life. If we try to do that, we'll deal with that in just a moment. And let's say OK right there. Why do I always forget to turn my email off? Anyways, let's come over here and we will now come into this joint right here. And if you want, you can rename it. Okay, and this one would be plunger to body. And what we're going to do is we're going to use that little arrow right there, or you can just right click and go edit joint limits. That's what the little arrow right there is for. And we are going to limit the motion in the sliding direction because a cylindrical joint can either rotate or slide. We're going to set a minimum to it. And the minimum right there at 0 is pretty good. If I look at it from the perfect side right here, you can see there might be a little bit of space right in there. Let's try what happens if I set that to -1 millimeter. That ties it up almost perfectly. That gives us a pretty perfect range of movement right there. And let's go to our maximum. And we should be able to just click and drag right here. But I'm just going to try typing in some numbers and let's try 80. We don't want to come much further than that. 85 right there. If you go much further than that, that syringe is going to pop out and you're going to lose all sorts of control. So we'll just click on OK right there. And now we've got our syringe stuck in there. We've limited the range of motion, but we can't see that yet because when I pick that up and drag it, everything still moves. We need to tell it what's supposed to be moving and what's grounded. So what we'll do is we'll just come in here and I'll make the syringe body. I'll right click on that and I'll tell it to ground the syringe body. And we'll just continue from their position. You can see a little grounding tag pops up in there, and this little pin shows up right on here, showing that that is grounded. And now, if I grab this end and slide it up and down, it slides up and down, and it remains stuck inside the syringe, which is great because now we're going to be able to use it in some other components as we build up larger and larger assemblies. Okay, so go ahead and save that. There is a 30 milliliter syringe body. Go ahead and do that for the 20 milliliter syringe and the 10 milliliter syringe, and you'll have a selection of syringes that can move up and down and rotate back and forth, and we can start putting them together. If you got a sense for how that jointing was working, you now have a clamp that will go around a 30 milliliter syringe that you could clamp right down here. And you also have a cap that can go on the head right there. Go ahead and try that. We're starting to get onto some pretty cool stuff. Have fun.